Okay, guys. So today we're going to start with your Form 5 Chapter 1. Okay, Form 5 Chapter 1. So I'm not sure how you're doing for your Form 4. Okay, but for now, I'll just focus on Form 5 first. Then only I will do the revision afterward for Form 4. Okay. So I'm not sure how you learn and what is your performance, what you achieve for your Form 4 final exam. Okay. But what am I trying to tell you is that, okay, when you come to Form 5, you need to change slightly the way on how you learn. Because many people, when they come to Form 4, they used to they read a lot. They read. But when you come to the examination, when you come to any test, they do very badly. Okay. So that's a very common problem for majority of the students. They understand the concept, but they don't know how to apply. And what even worse is that majority of the students nowadays is that, okay, I don't know what I don't know. So this is the problem for majority of students. They themselves not even know what is their problem. Okay? They don't know what is their problem at all, right? So that is a big issue, okay? Because the problem is what? You guys don't have PT3 exam. So you don't know your performance there, right? And then now even worse, now UPSR also, they demolish it. They don't have the UPSR already, okay? So they replaced by those school-based assessment, which is kind of like quite useless, actually, to be frank. So many students, they don't know what is their own problem. So how are you going to understand your own problem first, okay? Because if you come to me, sir, say, sir, help me. I say, how I can help you? What you don't know? I don't know. I don't know what I don't know. So I cannot help you one. So you must first identify your own weakness first. So one of the simplest way for you to identify your own weakness is that you must do good quality question. You must always do some good quality question. So what do we mean by good quality question? Okay, I want you all started from Form 5, try to do more on the trial exam paper. Do the question from trial exam paper, or we call it state paper. And also you want to do some past year question, PYQ, past year question. These are good quality question. It's not advisable for you all to do the question from any reference book, okay? Because sometimes the question for reference book might be too easy or they might be too hard, all right? Some students can do all the questions from reference book, but they cannot do a single question in SPM. There are quite a number of students like that, okay? So if you really want to do the question, do some good quality question, like what we will do today, like this, okay? Like the question from Perlis, the question from Pahang, all these state paper. So the quality is there. Okay, so this is something very important. So don't keep on reading already when you come to your Form 5. You have to start doing question. When you do the question, then only you know what is your weakness. Then only you can find some help. Like for example, if you keep on doing the question, you found that you always stuck at sort. Okay, then which means your sort is not good. Maybe you can ask your school teacher, you can ask me, you can ask your friend who know. At least you know what is your problem, okay? When you keep on doing question, you always start at mole. You don't know how to do the mole calculation, for example. Then you find a way, maybe you go to watch my YouTube video, you ask your friend, you ask your school teacher or what. So you must first understand what is your own problem first. Because if you yourself don't know your problem, no people can help you. All right. Sorry for taking up so many time to talk about all this bullshit thing, but it's so important, okay? Because many people were so lost. Many students were very lost, okay? Okay, so now let me give you the overview, what we will learn in the Form 5. So in your Form 4, there are total 8 chapters, okay? When you come to Form 5, there is only 5 chapters, okay? There's only 5 chapters in your Form 5, okay? All right? So, but Form 5, the chapters will be more longer, okay? Form 5, the chapters, okay, might be a little bit longer, okay? Hold on, All right, come. So, we have chapter 1. Chapter 1 is called Redox Equilibrium. No need to copy all this thing. I just give you a quick overview. I will tell you what we will do in this 1 year, okay? Chapter 2 is called Carbon Compound. Okay, chapter 2 is called Carbon Compound. Chapter 3 is called Thermochemistry. Chapter 4 is called Polymer. And chapter 5, okay, is called industrial chemistry. Okay, all right. So your chapter 1 will be the longest ever chapter you will encounter in these 2 years. Okay, chapter 1 itself, we will take approximate 4 months. Okay, we will use approximate 4 months just to learn about chapter 1. And chapter 1 is the hardest chapter in the entire Form 4 and also the entire Form 5. So I want you to stay focused and don't miss out any lesson if possible. If you miss out the lesson, please get the recording, because if you miss out one lesson, you might feel very lost already, okay? But don't get frightened by me. You follow my step, one by one, step by step, you will be fine. So carbon compound, we will spend about 2 months for it. Thermochemistry, we will spend 1 month, okay? Polymer, about 1 month. Industrial chemistry, about 2 weeks, okay? So this is the basic planning. This is the basic planning for this year, okay? So we will spend a very, very long time on redox equilibrium. So like what I say, so far, none of you actually, so far, none of you actually started with your, so far, none of you already started with the chapter 1 in your school. So I assume you are just a white paper, you know nothing, which is good. That's why I'll teach you from scratch, and I'll teach you very, very slowly, okay? So that you can follow me, okay? So let's start. So the first thing that you need to learn today, the first thing that you need to learn today is this. You need to understand the word called redox, okay? So what is redox? The word redox comes from 2 words. The first word is R-E-D. The second word is O-X, re and ox. So the re means reduction. So there is a chemical process called reduction. The ox means oxidation. So these 2 words very important. You will keep on, you will be bombarded with these 2 words for the next 4 months. In the next 4 months, I'll keep talking about these 2 words until you want to vomit. Yeah, reduction and oxidation. So what do we mean by redox? So sometimes SPM can ask you a simple question. What is redox? Okay, they can ask this. What is redox? And they give you 1 mark in SPM. So what is redox? Redox means that you have reduction and also you have oxidation. These 2 processes, they occur. You can use the word occur, you can use the word take place, you can use a simple word happen, doesn't matter, okay? All right, at the same time. Okay, when you have oxidation process and reduction process, these 2 processes happen at the same time, that is called redox. You must have both. If let's say this chemical reaction only got reduction, don't have oxidation, it's not a redox. If this chemical process only have oxidation, don't have reduction, it's not a redox. Redox must have reduction and oxidation happen at the same time. Sometimes the school, they don't, sometimes the textbook, they don't use at the same time. They use a very fancy word. They say reduction and oxidation occur simultaneously. Same thing lah. Simultaneously means at the same time. Okay? So make sure everyone know the definition of redox. What is redox? They always ask this in your paper too. Okay? You write this, you are going to get 1 mark. So that's the first thing. Okay? What is redox? Oxidation and reduction happen at the same time. Then some student might ask, Mr. Martin, can we write oxidation first, then only reduction? Can we write oxidation and reduction happen at the same time? I put oxidation in front. Can or cannot? Can. The sequence doesn't matter. It doesn't matter you write oxidation first, or it doesn't matter you write the reduction first. It doesn't matter. Most importantly, you write it. Okay? So that's the first thing we learned today. Okay, up to this moment, can you guys please respond to me in the chat box? Remember, send a message to the public space. Are you guys okay with what is redox so far? Okay, can. Very good. Okay, very good. So oxidation and reduction, these 2 processes happen at the same time. Okay, happen at the same time. So that is what we call redox. Okay, so now the next thing we need to know is this. What is oxidation? What is reduction? These 2 are something new for you. Okay, so they are total 4 different methods. So we have 4 different methods in order to determine. Okay, we have 4 different methods to know whether the process is oxidation or reduction. Okay, we have 4 methods to determine this chemical process is oxidation or this chemical process is reduction, because these 2 words is new for you. In Form 4, maybe you heard about neutralization, you heard about combustion, something like that. Okay, but you never heard about oxidation and reduction in Form 4. That's why it's something new for you. So how am I going to know this chemical process is oxidation or this chemical process is reduction? How to know? Okay, let me teach you a very simple way, and then we will do some past year question directly so you know how to apply. So let's look at it. So there is a very important table for you. Okay, you see, so this is the method. Okay, so we have 4 methods. Okay, the first method is you can look at the oxygen. We call oxygen method. Second method is called oxidation number method. Okay, we will learn what is oxidation number later on, no worry. Then we can look at hydrogen method. Then we can look at the last one called electron method. No worry, when you first started, of course, you'll feel confused one, which is completely normal. Yeah, there are 4 methods we can use. Okay, so I teach you a very simple way to memorize first. Then I will explain to you one by one. Okay, I teach you a simple way to memorize first. Okay, so how to memorize it? So I teach you a simple way to cheat. So look at the first letter. So look at the first letter here. You see, right? This first letter is O. This first letter is O. If the first letter is the same, put a plus. O and O. The first letter is the same, plus. O and H. The first letter is different, put a minus. O and E. The first letter is different, put minus. So here, everything terbalik. Plus, plus, minus, minus, terbalik. Minus, minus, plus, plus. Okay, what do I mean? If this chemical process, plus means gain. The plus means gain or increase. Okay. The minus here means lose or decrease. So if this chemical process gain oxygen, it is oxidation. For example, let's say this is me. I'm a human. Initially, I got 4 oxygen in my hand. Okay, I got 4 oxygen in my hand. So when I undergo a chemical process, now in my hand got 7 oxygen already. Okay, so now my oxygen increase. So when I increase the oxygen, I undergo oxidation process. Same thing like terbalik. If I decrease the oxygen, I undergo reduction. So let's say initially I got 4 oxygen on my hand. So now 4 oxygen now all in sudden become only 1 oxygen. So I lose oxygen, right? From 4 oxygen now only left 1. I lose oxygen. So that is reduction. That's it. So this is oxygen method. We will learn more later. Next one. Oxidation number. Oxidation number we will learn later also. No worry, okay? So this one a little bit tricky, we'll learn later. Okay, next one, same thing, hydrogen. So if you lose, minus means lose. If I lose hydrogen, I undergo oxidation. If I gain hydrogen, I undergo reduction. So same thing. Let's say initially I have a substance. Okay, on the left-hand side, let's say I got WH4. I got 4 hydrogen on the left-hand side. Go to right-hand side, become WH2. From 4 hydrogen become 2 hydrogen. So what happened? I lose oxidation. Hydrogen. Okay, I loses hydrogen already. So when I lose hydrogen, so look at hydrogen. Lose means minus. So lose hydrogen means oxidation process. So that's it. Okay. So by looking at these 4 different perspectives, then you know already whether the reaction is oxidation or reduction. So same thing, if I gain electron, if this chemical reaction gain electron, if I receive electron from other people, I undergo reduction. If I lose electron, I donate electron to other people, I undergo oxidation. Okay, so this table is the most important thing in your entire chapter 1. If you don't know this table, you cannot move on with chapter 1 anymore. So of course, when you first started, you'll feel confused, which is okay, which is normal. Okay, so how are you going to familiarize yourself easier and faster? Take a piece of paper, this table, copy for a few times. Every day, copy this table for one time. Do it continuously. Maybe 1 week you copy 3 times. Do it continuously for 1 or 2 weeks. Then you will be able to remember. You won't forget already. Okay, this is very, very important. Okay, you must know this table. Okay, now, why this table is so important and how the question can be tested in the real examination, how actually they can ask us the question. Okay, right, so let me show you how the question can be asked. So let me show you the question here. Okay, so this question is all coming from good quality question. All the question I'm showing you today, they are coming from trial exam paper. Okay, they are coming from trial exam paper. So let me show you the first one. This is the first question coming from Pahang, and also this is coming from Malacca. Okay, so what they want? So they say, first one, Pahang question, which of the following occur in reduction reaction? Which of the following occur in the reduction reaction? So reduction. So how I do it? So remember, let's do a table. Oxidation, reduction. So there are 4 methods. First method, oxygen method. Second method, oxidation number method. Third method is hydrogen method. Fourth method is electron. Okay, 4 methods. So how to remember? Look at the first letter, O and O plus, O and O plus, O and H different letter minus, O and E different letter minus, terbalik, minus, minus, plus, plus. So what they want? They want reduction. So focus on reduction here. So reduction, gain oxygen, yes or no? Oxygen, reduction is what? Minus, minus means lose. So it's wrong. So let's look at B, gain electron. So reduction, electron, electron is plus, plus means gain. So the answer is B. So can you guys please type in the chat box and let me know, are you okay with this concept so far? So this question is very straightforward. If you understand the table, if you can memorize this table, it's super, super straightforward. Same thing, if you don't know this table at all, you cannot do. Okay, if you don't know this table at all, you cannot do. That's why this table is so important. Yeah, this table, it is so important. Okay, so now let's move on. Let's try. I do a few more, then I let you try. Okay, I do a few more with you all. Then, okay, I let you try. Okay. Okay, come. Yeah. This is Malacca paper, same thing. Which of the following statement does not correctly describe the reduction? So does not means you want something wrong. Something wrong. Lose oxygen, yes or no? Oxygen, lose oxygen, it is reduction. Yes, but we're looking for something wrong. Gain hydrogen, yes or no? Hydrogen, gain hydrogen, reduction. Yes, but we want something wrong. Lose electron. So let's look at electron. Electron, lose it, should be oxidation. So wrong, because we are looking for something does not correct. So the answer is C. Okay, so actually it is very, very straightforward. You know this table, you are good to go. Okay, you know this table, you are good to go. Okay, so let me copy this table first. Okay, so now let's try another one. Okay, here. Okay, this one. So this is a question from Johor. This is a question from Johor. Probably you want to try this. Try these 2 questions. Type in the answer in the chat box. Let's say for the first question, the answer simply say let's say the first question, the answer is A, second is B. Simply say you type A, comma B in the chat box. Okay. Let's say the first answer is C, second one is donkey. You type in the chat box. Okay. Let's say you don't know how to do the first question, you type cross. Second one, you know how to do, you can type B. If both questions you don't know, you type both crosses. Okay. I want at least you reply me. I want you all to reply me. Come on, let's try. Let's try this. You are allowed to refer to this table by today. Okay, for today, this table I will give you. But in another 1 or 2 more lessons, you need to memorize this table on your own. Come on, let's try it. Okay, very good. Okay, very good response so far. Fantastic, guys. A and B, All right, fantastic. So just refer to the table, gain hydrogen, hydrogen gain, reduction, that's what they want. Okay. So the second one, it's Reduction also. So reduction. So let's focus on this row lah. So what they do is that, okay, gain hydrogen, okay? So reduction, hydrogen plus means gain. So it is very, very straightforward, okay? If you understand this table, if you understand this table, everything will be easy for you, okay? Everything will be easy for you, okay? So that's the first thing that we learned today. Okay, come on. Let's move on and learn something new. So this is first part for today. Okay, so the second part for today, the second part that we need to learn today is this, okay? Let me move you back. Okay, so the second thing you need to know is this, okay? All right, so now today I'll teach you probably two methods, oxygen and hydrogen. If we got time, then I teach you oxidation number method as well. So you see this four method, this one is easy, this one is easy, this one is hard, and this one is hard, okay? So in chemistry, you see, this is the one, easy, and hard. So SPM normally will ask you the hard one. The easy one, they seldom ask, right? But we have to start from the easy one. So today, I'll teach you these two methods first. If we got time, we learn this method as well. Okay, one by one, we learn slowly, no rush. We are not rushing. Okay, first lesson is always the most important one. I do super slow so that you all can follow me. Okay, let's start with the first one. Come on. The first method is called oxygen method. Okay, so listen carefully. So if you guys understand oxygen method, then the remaining part will be easy, okay? Because many method, they are very similar one. There are many method, actually, they are very, very similar one. So if you understand the first method, the other method would be quite easy for you, okay? So let's start with it. So for oxygen method, so what we need to do, okay? How to do oxygen method and what is it, okay? So let me show you now, okay? So if you want to do the oxygen method, okay, first of all, you need to understand a very important thing. We call it as apple to apple comparison. Okay, we need to do a very important thing called apple to apple comparison. Okay, so what do we mean by apple to apple comparison? Okay, so let me show you something first. Let me show you something first. Okay, all right, here. Okay, so oxygen method, we only focus on oxygen. So we only focus on whether we gain or lose oxygen. Okay, we don't look at other things. Okay, so what is the strategy that you need to use? Okay, this strategy can use for any other method. We call it apple to apple comparison. Okay, what do we mean by apple to apple comparison? Okay, listen carefully. So when you do apple to apple comparison, you must always choose the right person to compare. Okay, you must always compare the right apple. You cannot take apple compare with durian. Cannot. You cannot take apple compare to rambutan. So how to choose the right apple? Okay, how to choose the right pair to compare? Okay, so listen carefully. So there are three things you need to do here. First thing, you always need to choose one fella from the left, and then you always choose one from the right. So must be one left and one right. You cannot choose two from the left. You cannot choose two from the right. Must be one from the left, one from the right. Okay? So you must always choose something that is related. Choose something that is related. No worry, later I'll use 2 to 3 examples to show you, so you will have a better idea. Okay? So then you have to be careful with the sequence. Okay, so you have to be very careful with the sequence that we are doing. When you're doing the comparison, is always left go to the right. You cannot terbalik. You cannot go the other way around. You cannot compare right to the left. Okay, what do I mean, sir? Okay, the best way to learn is by example. So I will use 3 examples to show you so that you have a better idea. So if after 3 examples you still very blur, please ask me. Okay, so the first example, let me teach you this. So the first example, we have something like this. This is a magnesium, and then this is a copper oxide. This is magnesium oxide, and this is a copper. Okay, all right. So how are we going to use oxygen method to do this question? So first of all, look at the step. First, go to choose the right, one further from the left and one further from the right, choose something that is related. Okay, see, let's say I choose one apple from the left. The first apple I choose is magnesium. So can I choose copper oxide already? Cannot. You must choose one apple from the left and one apple from the right. So now the right-hand side got two apples, right? The right-hand side got two apples. Which apple we should choose? They must be related to the left. Can we choose copper? Cannot. Magnesium and copper has nothing related, no common thing, nothing related at all. Magnesium, copper, totally different. You will choose magnesium oxide. Why? They got relationship. This is magnesium oxide. Both of them got Mg. So at least you can see they are related. Okay, so these are the apple that you want to compare. Let me know in the chat box. Are you okay so far? Okay, always choose the right pairing for comparison. So can we do a comparison now? Yes, let's look at it. Let's look at the red color arrow. Would you compare always left to the right, not right to the left? So let's say now I compare the left to the right. So left to the right, what you can see, on the left-hand side, magnesium is alone. On the right-hand side, magnesium sticking with oxygen. Here, magnesium tak ada oxygen. Here, the magnesium ada oxygen. So from no oxygen become got oxygen. What happened? Gain oxygen. Okay. So now you can see already magnesium gain oxygen. So okay, magnesium increase oxygen. So as what we learned today, the 4 different methods. So when I gain oxygen, what process that is happening? Oxidation. Okay. So magnesium undergo oxidation. So magnesium undergo oxidation. If you don't want to say magnesium undergo oxidation, you can put a past tense like this. You can also write, okay, magnesium is oxidized. Make it a past tense. Okay, same meaning, right? Magnesium is oxidized. Okay, magnesium sudah undergo oxidation. Same meaning, right? So you can write either way. You can write the first one or you can write the second one, up to you. Okay, so magnesium undergo oxidation already. Okay, now let's choose the second apple to do comparison. So now the second apple is copper oxide. So now compared to another apple, this one, copper oxide and copper, they are related, right? Why? This fella got Cu, this fella got Cu. So they are related. So from here to here, remember, left compared to the right, not the right compared to the left. The sequence is important. The sequence is very important. Left to the right. So left-hand side apple compared to the right-hand side apple. So what you can see, on the left-hand side, the copper got oxygen. On the right-hand side, copper don't have oxygen. So what happened? This fella, copper oxide, lose oxygen. So when you lose oxygen, what happened? So as what we learned, oxygen, if you lose it, so it is reduction process. So it's reduction process. So you can say that this fella, copper oxide, lose oxygen, copper oxide undergo reduction. If you don't want to say the word undergo reduction, I write wrongly, sorry, guys, my bad. Okay, you can say undergo reduction. If you don't want to say undergo reduction, you also can use a past tense. Copper oxide is reduced. Sudah undergo reduction, also can. So now look at it. So in this chemical reaction, you have oxidation. In this chemical reaction, you also got reduction. So when oxidation and reduction, these two processes happen at the same time, this whole chemical reaction is a redox. Okay, so this is redox reaction. So guys, up to this point, is it okay so far? So it's not very hard, like what I say. You just need to make sure you choose the right apple. If you choose the right apple, you do the right comparison, everything it's easy. Okay, everything is easy. Okay, if you're able to do this. Okay, right? Not very hard one, but it all begin with choosing the right apple. Okay, it's all begin with choosing the right apple first. Okay, so we're done. Come on. So let's do a few more. Okay, come, let's do another few more. Okay, example number 2. Okay. Later, I will let you all to try. Okay, later, I will let you all to try some questions later. Okay, but now just follow my footstep. Let me guide you first. Okay, let me guide you step by step. Okay, example number 2. Okay, so let's say I go for another example. It look like this. Okay, all right. Here we have, okay, here. Let me do it like this, okay? PbO2, sorry, PbO2 plus C become PbO plus CO. Okay, same thing. We are now still focused in oxygen method. Other method, don't bother yet. Okay, so let's choose the first apple. So the first apple I choose is what? This one lah. One apple from the left. So when you choose one apple from the left, you need to choose another one apple on the right. So among these two apples on the right, you will choose the first or the second one to compare. Guys, you choose the first or second one to compare with the apple. Okay, very good. You choose the first one, right? Because at least you see something related, right? True or not? Okay. This fella got PB, this fella got PB. You can see, okay, they got relationship lah. They got relationship. So that's it. So compare left to the right. Left hand side, the PB got 2 oxygen. Right hand side, the PB got 1 oxygen. 2 become 1. Oxygen become lesser. So lose oxygen. PbO2 loses oxygen. So as what we learned today, when we lose oxygen, the process is reduction process. The process, it is reduction process. So reduction of PbO2 undergo reduction, or you can say is reduced. Okay, let's say I use the past tense, settle. So now let's choose the next apple to do the comparison. So the next apple that we want to do the comparison is here. Carbon is another apple compared with CO. So these two are related, right? Here got C, here got C lah. So on the left-hand side, the carbon come alone. On the right-hand side, the carbon sticking with O. So no O, got O. So increase in oxygen. So the carbon gain oxygen. So when you gain oxygen, you undergo oxidation. You can say undergo oxidation, or you can say is oxidized. So this chemical process, is it a redox, guys? Is this a redox process? Yes or no? Is this chemical process a redox? Yes or no? Yes, right? Because ada oxidation, ada reduction. When you have oxidation, you have reduction. These two processes happen at the same time. Yes, it is redox. Yes, okay? So settle. So it is redox. So done. Okay? So don't think very hard, right? So as long as you understand the logic, okay, as long as you understand the logic, you are good to go. Okay, you are good to go. It's not very hard actually. Okay, right. So now let's look at here. Let's look at one past year question. So not past year, state paper. Let's do one state paper. This question is from 2022 Police. Police trial exam paper. Soalan percubaan Police. So they give you this chemical equation lah. They give you this chemical equation. They ask what is the reaction happen on copper oxide. So copper oxide is this fella. So when you want to know what happened, you must choose the right apple for it. Copper oxide compare with the apple, copper. Left hand side, this copper got O. Right hand side, this copper don't have O. So what happened here? Lose oxygen. So lose oxygen is what process? Anyone can type in the chat box to let me know. Lose oxygen is what process? Okay, fantastic. Lose oxygen is reduction. So the best answer is A. Quite easy, isn't it? Okay. That's exactly how the question can be tested in the real exam. It's that easy only. Okay. Choose the right apple. Do the right comparison. You are good to go. As simple as that. Okay. That's it. Okay. Now, let us increase the difficulty. Okay. Let us increase the difficulty a little bit more. Okay. When you come to chemistry, another very important words is this. Okay, in chemistry, you will see this one, these important words. This one might be a bit confusing. So I'm gonna go very, very slow to make sure that you really can get the idea. I'm gonna go very slow to make sure you can get the idea. Okay, so listen carefully. So this is the side notes. Okay. So in chemistry, okay, so we have some super agent, we have some special agent. Okay. So you see, when you watch some not to say superhero lah, you watch some movie, okay, you can have 007, those like secretive agent, isn't it? So chemistry also got some secretive agent, okay? So you have two agents, listen carefully. The first agent called oxidizing agent. The second agent is called reducing agent. Okay, what do we mean by oxidizing agent and reducing agent? Oxidizing agent means what? You are the agent to oxidizing. Oxidizing means you let other people to undergo oxidation. So you go to let other people or other substance to undergo oxidation. You oxidizing ma. Oxidizing means you let other people to oxidation. Okay, undergo oxidation. This will be a bit confused. No worry, I go very, very slow. Reducing agent. I am the agent. What I do? Reducing. Let other people to undergo reduction. So I go to let other substance undergo reduction. Okay, what do I mean? Okay, you see, so everyone take a look on this. Today, this is substance A, or this is me lah. This is me. You mix me with oxidizing agent. Okay, you mix me with a fella. This fella is called oxidizing agent. Okay, some people say, Mr. Martin, why sometimes in the books I saw they write oxidizing agent, some they write oxidizing agent. The S and the Z, it doesn't matter. This has nothing to do with chemistry. This has something to do with English. Whether you are learning the UK English or you're doing the US America English, it's okay one. Both also acceptable. It's just English only. No matter you write S or Z, both are okay. Yeah. So if I am a substance called A, I mix with oxidizing agent. So what happened? Oxidizing agent, what they will do? They will let me undergo oxidation. So later on, the A will undergo oxidation. So oxidizing agent let other people undergo oxidation process. Same thing. Today, if this is a reducing agent, if I mix with reducing agent will make me undergo reduction process. Okay. So when I say agent means what? You want to help other people. Agent means you want to help other people. Oxidizing agent, you help other people undergo oxidation. Reducing agent, you help other people undergo reduction process. Okay. So this is something very important. Okay, now the next thing. How on earth we can know the substance is oxidizing or reducing agent? This will be very, very, very tricky already. This will be very, very tricky already. Okay, so I put 5-star here so that you know how important it is. Okay, not 1-star, not 2-star, not 3-star, 5-star. So this concept very important. So what is it? So listen carefully. Okay, when you come to chemistry, you need to understand this. Okay, you need to understand that all the chemical substance, they will always act or they will always behave as the special agent for the opposite, okay, for the opposite process okay, that themselves undergo. Okay, this will be very tricky. This one will be very, very tricky. So you will be the agent for the opposite process that you yourself undergo. Okay, all right. So what do I mean? Okay, what do I mean? Okay, let's say I am a substance A. So let's say I am substance A. Me, myself, undergo oxidation process. I undergo oxidation process. Okay, I undergo oxidation process. So I will be agent also. When I undergo oxidation, I am qualified to be agent. So the agent will be opposite of this. So if I undergo oxidation, I will be the opposite agent. So I will be reducing agent because the opposite of oxidation is reduction. So I am reducing agent. So you will always be the agent for the opposite process that you yourself undergo. Let's say I have another substance called substance B. So I have substance B. Substance B, this substance undergo reduction. So if I undergo reduction process myself, so who am I? So if I undergo reduction process, I will be opposite. So I will be the opposite agent of this. Reduction opposite is oxidizing. So I am oxidizing agent. Okay. So when you know what process that you yourself undergo, you will know exactly what agent you are. So I undergo reduction, I am oxidizing agent. I undergo oxidation, I am reducing agent. So this part might be a bit confused. Let me know, are you guys okay? If you are okay, can you type okay? If you don't understand, put a cross in the chat box. Let me know. It's okay to say not okay, right? So you have to be very, very careful with this. Okay, all right, good. So I can see probably there are so far got one. Okay, got one students not really understand. Okay, never mind. Is there any other don't understand? Is there any other student who understand? Okay, so let me go one by one. All right. Okay, so I hope I pronounce your name correctly. Jiriri Hashan. Okay, so Jiriri Hashan. So let me go through this one. Okay. So I want you to follow me. I want you to follow me. Okay. First of all, okay, do you understand what is oxidation reduction? The basic thing first. Do you understand basic oxidation reduction first? Okay. So now allow me to ask you a simple question. Let's say, okay, now A plus BO become AO and B. Okay. So I want you to answer me, Dri Hashan. So now I want to do apple to apple comparison. So which one I should compare? You let me know the number, who and who I should compare when I do apple to apple comparison. Let me know which pair I should compare. If I choose A here, I should compare with who? Okay, 3, 1 and 3, 2 and 4. Very good. Okay, I choose 1 and 3, 2 and 4. Okay, let's say I 1 and 3, I compare apple to apple. Okay, so can you let me know A to AO, what is the process happen on A? What process A undergo? What process A undergo? Very good. Oxidation. That's it. Okay, why? For the other students, you can see A become AO. What happened? Gain oxygen. So when A gain oxygen, according to the table that we learned today, gain oxygen means oxidation. So when you undergo oxidation, what is the agent you are? So remember, you will always be the agent for the opposite process that you undergo. If you undergo oxidation process, what agent you are? That's it. Reducing agent. So do you get some idea now? Okay, let's try another one. Okay, guys, come on. BO to compare with B. Apple to apple comparison. BO to B. Got O, don't have O. What happened? Loses oxygen. So lose oxygen, what happened? BO undergo reduction, isn't it? Lose oxygen is reduction. So guys, can you type in the chat box? If BO undergo reduction, what agent it is? What agent it is? Fantastic. Very good, Haida. All right, very good. Duncan. All right, Zoe, Eliza. All right, very good. Oxidizing. You get it? Okay? As simple as that. So don't mess up. Okay? I'm talking about two things. First of all, I tell you all, what do we mean by agent? Agent means what? I can help other people to undergo a specific process. If I am oxidizing agent, I help other people undergo oxidation. If I am reducing agent, I help other people undergo reduction process. That's it. So that's what the agent do. Then how on earth I know this fella, this substance is what kind of agent? So I must know what process they undergo, because whatever process you undergo, you will be the opposite agent. If you undergo oxidation, you will be opposite. Opposite of oxidation is reduction, reducing agent. If you undergo reduction, you will be opposite agent. Opposite of reduction is oxidation, oxidizing agent. That's it. you will always be the opposite agent for whatever process that you have undergone. That's it, okay? So simple as that, okay? As simple as that. So now we can come back here and we can complete the remaining thing already. Come. Example number 1 just now. Okay, so like, come on. Maybe we'll open up a new one. We open up a new one, and maybe I give you 2 minutes for you to try together. Okay, for you to try together with me. Okay, so I do example number 3 with you all. Okay, I do example number 3 with you all. Okay. All right, example number 3. Okay. So let's say example number 3, we have this Zn, zinc, react with oxygen O2 to become 2 zinc oxide. Okay, this question is not hard, but it's a bit tricky for some people. It's a bit tricky for some people. Okay, listen carefully. Okay, listen carefully. How are we going to do this question? How are we going to do this question? Okay, first of all, same thing, choose the apple and apple comparison first. Always choose one apple from the left, one apple on the right. So first apple on the left, let me choose this fella. So apple on the right, no choice. There's only one here. Of course, I choose this one. So when you compare the left-hand side, the zinc, right-hand side, the zinc come with O. Quite easy lah. No O, got O. So here to here. So what happened? The zinc actually gained oxygen. So gain oxygen means reduction. So when zinc undergo reduction, it will automatically become the opposite agent. So the zinc itself become reducing agent. Now remember, when I undergo oxidation, I will be reducing agent. It always go opposite. It always go terbalik. So settle. Now let's look at the another one, another apple. So now I choose another apple on the left. So which apple I want to compare the right? Same thing. So I still compare with this fella. So, sir, I thought just now we compared already. I didn't say you cannot repeat, right? I only say you must compare the left and the right. Choose one apple on the left and one apple on the right. I didn't say you cannot compare back to the same apple, isn't it? Okay, you can compare back to this apple. Although this apple just now compared with here already, you can reuse the apple and compare with this fella. It's okay. So let's do it. Left-hand side, O2, 2 oxygen. Right-hand side, 1 O. Now, be careful. Many students, they will start to say, sir, here got 2 O, right? Here got 2 O. By right, oxygen doesn't change. Okay, listen carefully. When you do apple-to-apple comparison, please don't bother the number in front. All the number in front here only used to balance the equation. All the number in front here only used to balance the equation. When you do the apple-to-apple comparison, do not bother the number here. Don't look at the number in front. So only look at O2 and ZNO. This number 2, don't look at it. So O2 got how many O? 2. ZNO got how many O? 1. 2O become 1O. So what happened? Lose oxygen. So the O2 loses oxygen. So lose oxygen means reduction. When you undergo reduction, you are opposite, oxidizing agent. Okay? So guys, now, based on this question up to now, is it okay? So far, so good? Is it okay? If not okay, say not okay. So far, so good? Okay? So I want you all to be honest with me. Not okay, just say not okay. Don't feel bad. Wow, 40 people say okay. I am the only one who say not okay. I feel bad. No, don't think like that, please. Don't think like that, okay? I'll try my best to help you, but you just need to be honest with me. Can I? All right. So you see, guys, it makes perfect sense one. You see, you see, it makes perfect sense one. Why I say O2 is oxidizing agent. Oxidizing agent means what? You help other people to undergo oxidation. Make sense, ma? O2 give 1 O to the zinc, right? O2 give 1 oxygen to the zinc so that it becomes an NO. So when I give oxygen to the zinc, I let the zinc to gain oxygen. When I let the zinc to gain oxygen, I help the zinc to undergo oxidation, isn't it? That's what I do. Okay, same thing. The zinc will take one oxygen from O2. So when zinc take one oxygen of O2, zinc will let the oxygen to lose O. Zinc will let the O2 to lose O. When I let other people to lose oxygen, okay? So what is it? I let other people to lose oxygen. I let the oxygen to undergo reduction. When I help this oxygen to lose the oxygen, so I am reducing agent. Makes sense, right? Zinc is reducing agent. Why? I let the O2 undergo reduction. How I let the O2 undergo reduction? I take away O from the O2. When I let the oxygen to lose the when I let the O2 to lose oxygen, the O2 undergo reduction. That's it. So that's what happened. Okay. So when I am agent, I help other. Okay. So that's why don't confuse. First of all, you must know what the agent do. Oxidizing agent, what you do? You help other people undergo oxidation. Reducing agent, what you do? You help other people undergo reduction. How to know who is oxidizing agent, who is reducing agent? You just need to know what process it happens. Okay. If you undergo oxidation, you become the opposite agent, reducing agent. If you undergo reduction process, you become opposite agent, oxidizing agent. I keep on repeat, and repeat because this is so important. This is very, very important. Okay, that's it. Okay, so that's how it works. Okay, now the last example, this is for you. Maybe you can try to do. Okay, I would like you all to try to do this question. You can try to do this question. You do like what I did. Okay, you must know who gain or lose oxygen, what process it undergo, and what agent you are. So tell me three things. Okay, follow exactly what I do. Okay, draw the proper arrow, choose the right apple, do the right comparison. Tell me who gain or lose oxygen. Tell me who undergo oxidation and reduction, and tell me who is the oxidizing or reducing agent. Okay, so this one is a self-test for you all. Okay, so after this self-test, then we will move on to the hydrogen method, because I believe if you understand oxygen method, you shouldn't have a big issue when you move on to hydrogen method, because they are very, very similar. Come on. So this is a self-test for you all. This is a carbon. This is a carbon dioxide. And this is a carbon monoxide. So guys, all right, you can try. So you just need to follow exactly what I do, something like this. Okay, you try first. Come on. Okay, so once you are done, you type done for me. Okay, if you finish already, type done. So I want you to do like exactly what I do. Choose the right apple, do the right arrow, tell me what process it happens, tell me what agent it is. Okay, come on. Take your time, all right? Some might do it very quickly, some might take a longer time. It's okay. Don't compare with others, okay? Follow your own pace. Follow your own pace, yeah? Okay, guys. Okay, let's discuss on this question, yeah? Okay, first of all, please choose your apple, okay? Always choose one apple on the left first, always start from the left, okay? The apple on the left, let's say carbon. So you must choose one apple on the right. Right-hand side, you not even have a choice. Must be this fella lah. So left to right. So you want to go top, you want to go bottom, up to you. It's okay one, huh? So let's say go top. This carbon got no O, this carbon got one O. Remember when you compare this number 2, don't bother. Don't bother the number 2 in front. Only compare the formula, the number in front only for balancing. C becomes CO. You gain 1 additional oxygen. So you gain oxygen. So carbon gain oxygen. So carbon undergo oxidation. So carbon is reducing agent. End of story. So another apple to apple comparison. Choose another apple on the left, CO2. So you must choose one apple on the right. So this apple, although just now you used already, now you can use back the same apple. Okay, never mind. CO2 becomes CO. Remember the 2, don't bother. Okay, if you put the 2, you're confused already. Here got 2O, here got 2O. Cannot. The number in front, don't bother. Okay, don't bother. CO2 to CO. So what happened? CO2 got 2O, CO got 1O. So 1 oxygen went missing. So CO2 lose oxygen. So lose oxygen, undergo reduction process. When you undergo reduction, you become the opposite agent, oxidizing agent. End of story. Okay. So with that being said, we are all done with the oxygen method. Okay. So the first method is all done. Let me know in the chat box, guys. So far, are you guys okay with oxygen method so far? I want to make sure everyone okay first, then only and move on. Okay, guys, very good. Okay, very good. So you guys can follow, right? Okay. So I memang want to go so slow. I memang want to go this slow one. I memang purposely go very slow to make sure you really can understand. Okay. I go fast, no people can understand. No point. Okay, no point. I rather go super slow, but you can understand. Okay, now let's go on with hydrogen method. Hydrogen method is very, very rare in SPM. Not popular. Okay, not popular. But if you understand the oxygen method, you shouldn't have a big issue with the hydrogen method. Okay, hydrogen method, you follow exactly what oxygen method will do. Okay, you just need to focus now on hydrogen. Okay, hydrogen method is the least popular method among 4. So we have 4 methods. The least popular one is hydrogen method. Okay, so same thing now. We just need to focus on whether you gain hydrogen or whether you lose hydrogen. Okay, so if you understand the so-called oxygen method, you shouldn't have a big issue at all when it comes to the hydrogen method. Okay, let me show it to you. Okay, let me show it to you now. Right. So how to do the hydrogen method? How are we going to do the hydrogen method? Okay, so let's see. Okay, we will use 2 examples. Okay, I'll use 2 examples also to do the demonstration. Okay, I'll do the demonstration here. Okay, so let's say the first example. I'll show you one example and then I show you one K-but question. Okay, so example number 1. Let's say H2S, hydrogen sulfide, react with chlorine so that you become hydrogen chloride and you become sulfur. So same thing. Now we just want to focus on hydrogen. Okay, we just want to focus on hydrogen. Just now we focus on oxygen. Now we focus on hydrogen. As simple as that. Okay, all right. So same thing. First of all, choose the apple first. Always choose one apple on the left. Always begin with one apple on the left first. One apple on the left. So which apple you want to compare with the right-hand side here? Sulfur. Why don't you compare this one? Okay. Why don't you compare this one? You see, this fella got 2H. This fella got 1H. Looks good. But here the sulfur, why all the sulfur become chlorine? Cannot, man. No, there's no way sulfur become chlorine, man. Or in sudden become something else. Doesn't make sense. So if H2S and S at least make sense, man, why? Got sulfur. Then you can see This sulfur sticking with 2 hydrogen. This sulfur got no hydrogen. So from here, obvious, no? So you can see that from left to the right-hand side, the H2S lose hydrogen. Okay, now look at hydrogen method that we learned earlier on today. So if you look at hydrogen method, when you lose the hydrogen, it's oxidation. So terbalik, hydrogen method exactly terbalik of oxygen. When you gain oxygen, oxidation. Now, hydrogen terbalik. Okay, when you gain hydrogen, reduction. So hydrogen and oxygen exactly terbalik. Exactly terbalik, yeah? All right, opposite. So when hydrogen sulfide lose oxygen, so you undergo oxidation, all right? If you're not sure, just refer to the table. Just refer to the table. So when you undergo oxidation, same thing lah. You'll be the opposite agent. So you will be reducing agent. Okay? All right. So now another apple to apple comparison. So choose another apple, chlorine. Another apple is HCl. Does it make sense? Make sense, ma? Here the Cl got nothing. Here the Cl got hydrogen. So you can see already. On the left-hand side, the chlorine don't have hydrogen. On the right-hand side, the chlorine got hydrogen. So you can see, no? The chlorine here gain hydrogen. So when you gain hydrogen, chlorine undergo reduction, isn't it? Okay, remember, refer back to the table. Gain hydrogen means reduction. So when you undergo reduction, which agent you are? Opposite, no? So when you undergo reduction, you are the opposite agent. So you are oxidizing agent. End of story. Is this a redox reaction? Yes, because I have reduction, I have oxidation, redox, okay? So when oxidation and reduction process happens at the same time, then it is a redox process, okay? So now let me show you another example. So this is a K-but. This is a K-but, or we call it a HOTS. Okay, this is HOTS means higher order thinking skill. K-but in BM, kemahiran berfikir aras tinggi. Okay, so higher order thinking, critical thinking question. Okay, so how am I going to make this question become a K-but question? Okay, so K-but question, they can do something called 2-in-1. So 2-in-1 means that they can combine oxygen method, they can combine the oxygen method as well as they can combine hydrogen method. So this is special because just now, if you remember, all the example we use is purely oxygen method or purely hydrogen method, but now they can make it become a K-but, whereby we will use both. Two methods all come in together. No worry, no panic. Just do as usual. Just do it as usual. Okay? Right, let's say we have this ammonia react with copper oxide, become nitrogen gas, water, and copper. Okay? So no worry. Okay? Just follow my lead. Okay? I'll lead you. I'll teach you what to do. So first and foremost, before you do apple and apple comparison, don't be so excited yet. Always make sure when you have a chemical reaction, the first ever thing you need to do is what? Balance it. Always remember, whenever you get a chemical reaction, just balance it. Before balance the equation, don't ever do your apple and apple comparison. Okay, so I balance it quickly. Let me balance it. 2, 3, 3. That's right. 2, 3, 3, 3. Yeah. So you can balance yourself. So now let's choose the apple to compare. Let's choose the apple and apple to compare. So let's say I choose one apple on the left. Okay. So we choose one apple on the left. So tell me, guys, this apple on the left, I should compare with who? 1, 2, or 3? If I choose ammonia on the left, I should compare with who? 1, 2, or 3? Okay. Very good. Okay. Very good. I should compare with number 1. Okay. I should compare with number 1. Makes sense. This nitrogen sticking with hydrogen. This nitrogen not sticking with hydrogen. So obviously, you know which method you need to use. Hydrogen method, isn't it? So ammonia is actually losing hydrogen. So lose hydrogen, what process is happening? Oxidation, right? Lose hydrogen is oxidation process. When oxidation process takes place, you will be the opposite agent. You are reducing agent. Okay, you are reducing agent. End of story. Now, let's choose another apple to do comparison. Green apple. Copper oxide, now I want to compare with who? One or two? Copper oxide, who I compare? One or two? Okay, let me see the chat box first. Okay, very good. Okay, Duncan, Haida, Zoe, Eliza, Yingqi, Cynthia, Jayani. Okay, Xingning. Okay, very good. Compare with two. So that's why I say you must know which apple you should compare. That's the most and basic thing. Okay, you choose the right apple, you won't get wrong lah, right? Unless you're careless. No? So copper. So come to here. Okay, remember left to right, not right to left. Okay, so on the left, the copper sticking with O. On the right hand side, the copper got nothing, no O. So lose oxygen. No? So copper oxide lose oxygen. So lose oxygen, what process? We learned early on, oxygen method. Lose oxygen is reduction, isn't it? Okay, reduction. So when you undergo reduction, you are opposite oxidizing agent. Okay, that's it. All right, simple as that. So you see, this one, I not even need to purposely do it. You see, this is hydrogen method. This is oxygen method. I not even need to purposely think about it. I just choose the right apple. I see, this one, the oxygen disappear, oxygen method lah. This one, the hydrogen disappear, hydrogen method. I not even need to purposely memorize. I follow the flow naturally. I follow the flow naturally and I get answer already. As simple as that. Then some people say, Mr. Martin, this furler we haven't used, this copper oxide, nothing. Well, just now I only tell you, you need to choose one apple on the left and compare with the apple on the right. I didn't say you must use all the apple, right? Some of the apple, you don't want to use it. It's okay. Not to say you must use all the apple one. It's okay. All right? So with that being said, we are all done with hydrogen method. Okay, we are done with hydrogen method already. Okay, so the pace is quite good so far. So we have managed to complete two methods. Okay, guys, let me know in the chat box. How's everything? How's everything? Okay, not very hard lah. Not very hard lah. Can lah. Okay, can do lah. All right. So not very hard. Okay, it's actually doable. Okay, it's very, very doable. Okay. So if you really understand, you follow the logic, it's not that hard lah. Okay. All right. So let's see. Okay. Any question I can do with you? Okay. Any question here? All right. So, okay, here. Okay, this one. Oxidation number later. Okay. Okay, can. All right. So now I will teach you the third method, which is the most tricky method. Okay. Which is a super, super technical method. Okay. We will try to finish it in the next 30 minutes. I go very, very slow. If I cannot finish today, never mind. Okay. I'll finish it in next week. Okay. But this is very important. That's why I'm going to go very slow. Okay. So now let's do it. Okay, so now we have completed these two easy methods. So now we are moving toward to these two hard method. So I won't touch electron method for sure today, right? I will only touch oxidation number method, okay? So this is very, very technical, okay? I want to, hopefully, okay, I can teach in a way that most of you can understand. If let's say after this, you still don't understand, you can watch back the playback of the video. If you still don't understand, feel free to ask me anytime. Yeah, don't be shy. Ask me, please ask me, if you're not sure. So now let's look at the hard method already. So the hard method we need to learn is called oxidation method. Sorry, oxidation number method. Okay, so oxidation number method, okay, this is a very popular method in SPM. Super duper popular. Super duper popular in SPM. Okay. So when you come to oxidation number method, okay, so I will teach you two things. Today, I want to teach you a few things first. Okay. First of all, I want to teach you this. Okay, there are total 4 rules to determine the oxidation number. Okay, so you need to know what is oxidation number and how to get it. How are we going to find the oxidation number for a substance? Okay, hopefully in about 20 minutes time, whenever I give you a substance, you will be able to tell me the oxidation number for that particular substance. I repeat, hopefully in 20 minutes time, okay, whenever I give you a substance, you will be able to tell me, okay, what is the oxidation number of that particular substance. Okay, so let's start. Okay, so there are total 4 rules. Okay, I will go through one by one. I will gonna give you a lot of examples so that you can apply. You can apply whatever things that I want to tell you now. Okay, so rule number 1. Okay, so rule number 1. Okay, just a moment. Just one minute. Okay. Okay. All right. Come. So why oxidation number method is so popular? Okay, why oxidation number method is so popular? Because oxygen number method can use for all the cases. Every single case can use. Okay, like oxygen method can only use if the question got oxygen. Hydrogen method can only use if the question got hydrogen. Let's say you see, guys. Let's say I give you something like this: magnesium plus, okay, uh, this magnesium plus hydrochloric acid become magnesium chloride and hydrogen. Or maybe I go for another one. Okay, let's say this one. Sodium plus chlorine becomes sodium chloride. Do you think we can use oxygen method in this question? Yes or no? Can we use oxygen method in this question? No, right? Okay. Can we use hydrogen method in this question? Yes or no? Can we use hydrogen method in this question? No, right? You see that? So oxygen and hydrogen method, they're quite easy, but they have a weakness. Okay. Many case cannot use. If the question don't have oxygen, then tak boleh pakai lah. Cannot use already. Okay. So oxidation number method is so important and so popular because you can use in all situation. Okay, because you can use it in all situation. Okay, you can use in many condition or many situation. No matter the question got oxygen or not, no matter the question got hydrogen or not, oxidation method can be used. Okay, you can use oxidation number method. Okay, so let's look at the rule. Rule number 1. Okay, rule number 1, you need to know that the oxidation number of, okay, the oxidation number for element. Okay, oxidation number for element. Okay, it's always 0. So oxidation number for elements is always 0. Okay, allow me to ask a simple question here. Guys. Anyone of you here don't know what is element? Anyone of you don't know what is element? If you don't know what is element, can you type me? If you don't know what is element, can you type me for me? M-E. Okay, so let me teach. Okay, element is something you learn in Form 4, Chapter 2. Okay, Form 4, Chapter 2 are element. So what is element? Element is referred to anything that is made of one species. Okay, so anything that is only made of one species. Okay, what do you mean by one species? Okay, for example, let me give you a few example. Okay, zinc is an element because only one species, right? Only one type of substance here, zinc. Aluminium is only one type of substance. Aluminium only, nothing else. So it's one type of substance, one species only is element. O2, oxygen. Don't get cheated by two. Although you have two fella, but both of them are O. They are same species, right? Both of them are O. You only have one type of substance. So they are element. Let's say sulfur S8. Don't get cheated by number 8. Although you have 8 fella, but all the 8 substances, they are sulfur. All of them are same species. So they are element. So as long as you have element, all their oxidation number is 0. Okay? So when you have element, the oxidation number is 0. So you all must know what is element. Anything that is made of one species only. So that is element. So guys, carbon dioxide, is it element? Yes or no? Carbon dioxide, is it an element? Yes or no? No, because you got carbon, you got oxygen, you have 2 elements. You have 2 species. So you are not element. All right? So element must have only one species. Okay? So that's it. So if you have element, the oxidation number will automatically become 0. Okay, rule number 2. Okay, rule number 2. Okay? Oxidation number for ion, it's always same as their, okay, charges. Okay, oxidation number of ion is always same as their charge. Okay, so what is ion? Anything got charge. So if you know anything got charge, the oxidation number is exactly same as their charge. Example, you have Na plus. Is it ion? Yes, because you got charge. So Na plus got charge is ion. So for ion, the oxidation number is same as the charge. So it's positive 1. Okay. So let's say aluminium Al3 plus. What is the oxidation number? Copy back the charge, plus 3. So guys, here you have to be very careful. Here you have to be very careful. When you go for charge, in chemistry, when you write charge, you write the number, then only the sign, isn't it? Like oxygen, O2 minus. You don't write O minus 2. You write the number first, then only the charge. So charge, you always write number, then only the sign. But when you come to oxidation number, just like normal number, you must write the sign first, then only the number. Okay, so please be careful. So if I ask you, what is the charge for aluminium? 3 plus. What is oxidation number for aluminium? Plus 3. So there are some small difference. Okay, so let's say O2 minus. What is the charge? 2 minus. What is the oxidation number? Minus 2. Cl minus. What is the oxidation number? Minus 1. Okay, so make sure you note it. Nitrogen N3 minus. What is the charge? 3 minus. What is the oxidation number? Minus 3. So guys, can you please let me know in the chat box, which is very important. Do you guys know the difference between charge and oxidation number? Do you guys okay with it? So the arrangement, the arrangement slightly different. Charge 3 plus. Oxidation number plus 3. Okay? And this is very important because when you do mathematics, normally you don't show the sign, right? Normally you don't show positive sign, isn't it? But when you come to oxidation number, you must show the sign, no matter is positive or negative. Okay, so this is a tips. Okay, you must show the sign, for oxidation number. No matter it is positive or negative, because in mathematics, normally we don't show the positive sign, but not for oxidation number. Oxidation number, you must always show the sign. Okay, this is rule number 2. So now let's look at rule number 3. Okay, so rule number 3. Okay, so now we go for oxygen. Oxidation number of oxygen, it's always -2. Okay, oxidation number for oxygen, it's always -2. Okay, let me change a bit. All right. So the red color is important. Okay, so oxidation number for oxygen is always -2, except a few special cases, which I'll show later. Okay, let's say water got oxygen. So the oxygen here is -2. Magnesium oxide got oxygen. The oxygen here is -2. Okay, so let's say we go for something that looks weird. Carbon dioxide got oxygen. So the oxygen here is -2. Okay, so let's say aluminium oxide got oxygen. You don't bother how many oxygen it has. You don't bother you have 1 oxygen, you have 2 oxygen, or you have 3 oxygen. Don't bother. All the oxygen, the oxidation number is -2. That's it. The quantity of oxygen not important. Okay, no matter you have 1, 2, 3, or 11 oxygen, doesn't matter. All the oxygen, the oxidation number is -2. That's it. So you have 2 special cases lah. Okay, when you have O2. When you have O2, what is the oxidation number? O2 only have 1 species, right? So it's element. So as what we learned today, element, what is the oxidation number, guys? Element, what is the oxidation number? We learned just now in rule number 1. Very good. 0. Okay, O2, although you have O, but it's not -2 because O2 only have 1 species. So it's element. Element is 0. You see, just now, all the O here combined with something else. The O combined with H. The O combined with Mg. The O combined with C. The O combined with aluminium. So all these, they are not element. Okay. So when you are not element, the oxygen is always -2. But if the oxygen only come alone, if the oxygen only have 1 species, you are element, then you are 0. Okay, so you have to be very careful. Okay, that's it. Another one, which is super rare lah. They seldom ask in exam lah. For the past 25 years, they only ask 3 times. For the past 25 years, they only ask 3 times. So not very important. Okay, which is H2O2. So H2O2, the name is called hydrogen peroxide. If you cannot remember the name, doesn't matter. Doesn't matter. So H2O2, just like a water got 1 O ma. This is water with 1 more O, 2 O. That's it. Okay. Hydrogen peroxide, just a normal water with 1 extra oxygen. If you cannot remember the formula, if you cannot remember the name, doesn't matter. So in H2O2, this is another special case. In H2O2, the O here, it's -1. Okay, the O here is -1. Other than that, oxygen, it's always -2. Okay, other than that, oxygen is always -2. Okay, example, okay, let's say C2H5OH. Okay, so this oxygen, what is the oxidation number? This oxygen, what is the oxidation number? Somebody type in for me. Very good, not -2, right? Because this is not the special case. This is not the special case. Okay, let's say another one. Okay, all right, zinc carbonate. Wow, we have 3 oxygen here. So this oxygen, what is the oxidation number? What is the oxidation number for this oxygen? Very good, -2. Okay, what if I have this O3? O3 called ozone. Not in the syllabus. Okay, but what if they ask you, what is the oxidation number for the O in the O3? Fantastic, 0. Why? Because only got O ma, only 1 species. You are Element. So when you only have one species, your element. When you are element, zero. As simple as that. Yeah. So very good. Okay. So guys, seems that you guys have some good ideas. So if anyone already get lost, if you already get lost, if you cannot follow, can you type an X in the chat box? If you cannot follow already, you feel very confused, you can type the X. Okay. Okay, no worry. We are going to the last rule, and that is the last thing for today. Okay, I'm not going to put too many things for you, or else you just cannot take it. Okay, I'm not going to put too many things for you, or else you just cannot take it. Okay, so let's look at rule number 4, which is the last rule already. The last rule already. Yeah. So the last rule that we can see is this. Okay, the last rule is this. Okay, oxidation number. Oxidation number for hydrogen. Just now we have oxygen. Now we look at hydrogen. Hydrogen, the oxidation number, it's always positive 1. Hydrogen is always positive 1, except, again, 2 special cases. Okay, the 2 special cases, I'll talk about this in a short while. But let's look at the normal cases. Let's say normal case, water. Water, do you have hydrogen? Yes. So the hydrogen here, it's +1. You see, it doesn't matter how many H you have. As long as you have H, you have +1. So let's say we go for something different. Okay, let's say we go for sulfuric acid. Sulfuric acid also got hydrogen, right? All the hydrogen here is +1. Let's say we go for hydrochloric acid. Hydrochloric acid also got hydrogen, right? So it's +1. Okay? So let's say we go for some very weird substance. Let's say we go for some other weird substance. Let's say we go for CH3, C2H5OH. So this fella is ethanol. You will learn this in your Form 5, Chapter 2. So this fella is an alcohol. So this fella got hydrogen. This hydrogen also +1. This hydrogen also +1. Okay, no matter here got 5 hydrogen or here got 1 hydrogen, don't care. As long as you have hydrogen is +1. That's it. Very easy. Hydrogen always +1, oxygen always -2, except special case. Okay. So what is the special case we have? The first special case is H2 lah, hydrogen gas. Hydrogen gas, again, not H2. Both of them are H, only one species. So you are element again. When you have element, it is 0 lah. You know lah. When you have element, you are 0. Another special case, which is super rare in exam as well, which is called metal hydride. No need to memorize. Metal hydride means metal combined with hydrogen. When metal combined with hydrogen, you get metal hydride. Okay. So when you have metal hydride, okay, so like this, okay. Let's say we have, I change color lah. I use green color. Sodium is a metal combined with hydrogen. Magnesium is a metal combined with hydrogen. Aluminium is a metal combined with hydrogen. So when you have metal combined with hydrogen, you call it metal hydride. So in metal hydride, all the hydrogen here, they are -1. Other than that, hydrogen always +1. No worry, this one super rare in exam. Super rare in exam. So it's good to know lah. It's good to know, but the chances to be tested is super low, very low. Okay, so by using these 4 rules, now you can get majority of the oxidation number. Okay, you can get majority of the oxidation number already. Okay, so now let me show you using 2 examples how to use the oxidation number to do the apple to apple comparison. So let me use 2 examples to show you how to use the redox. So how to do the apple to apple comparison by using this so-called oxidation number method. Okay, I start with easy one first. Fe2 plus chlorine become 2 chloride. This one put 2, this one put 2, Fe3 plus. Okay, so no need to memorize, just show you only. Okay, so now let's say you have this question. Can we use oxygen method? No, there's no oxygen at all. Can we use hydrogen method? No, there's no hydrogen at all. So now we have to use oxidation number method. So when you want to do oxidation number method, first and foremost, first of all, you need to list out the oxidation number first. Okay? First of all, please list out all the oxidation numbers. You need to list out all the oxidation numbers, okay, on the left and the right. So can we do it together? So what is the oxidation number for Fe2 plus here, guys? What is the oxidation number for Fe2 plus? Anyone can type in the chat box and let me know. Okay, 2, wrong, plus 2, okay. So some people answer 0, wrong. Why? This fella got charged. When you got charged, you are ion. So ion, the oxidation number, copy the charge, rule number 2. So there are many of you type only 2, which is wrong. Remember, I say what? Oxidation number, always need to type the sign. You must put the sign, even though it is positive. So it is positive 2. It is positive 2. All right. So not 0. Why is not 0? Because you got charged. When you got charged, you are ion. When you are ion, the oxidation number must follow back the charge. Okay? All right, next one. What is the oxidation number for the chlorine here? What is the oxidation number for the chlorine here? Okay, very good. 0, because this chlorine is one species element. So it's element. Element is 0. Rule number 1. Very good. What is the oxidation number for this fella? Chloride. What is the oxidation number for chloride here? Fantastic, -1. Remember, when you have charge, you are ion. When you are ion, I will copy back your charge, -1. Okay? So some people say, sir, got 2 in front, no need to times 2. No need. Remember, I say what? All the number in front only for balancing purpose. All the number in front only for balancing purpose. So what is the oxidation number for Fe3 plus? So this fella got charge. Oxidation number, copy the charge. Plus 3. Must put the plus. If you only put 3, it's wrong. So remember, oxidation number must always show the sign. Despite it is positive or negative, no matter it's positive or negative, you need to show the sign. Very good. So once you list out the oxidation number, then only you do your apple to apple comparison. Then only you do your apple to apple comparison. So let's do it. Okay, first apple, Fe2 plus compared to Fe3 plus, because you can see something in common, right? So plus 2 to plus 3, what you can see? Oxidation number plus 2 to plus 3. So oxidation number, we don't say gain or lose one. Oxidation number, you don't gain or lose. You don't say I gain a number, I lose a number. No, you can say you gain oxygen, you gain hydrogen, you lose oxygen, you lose hydrogen. So oxidation number, normally we use increase or decrease. Plus 2 to plus 3 increase. So oxidation number increase. ON stand for oxidation number. Okay, oxidation number increase. So according to the oxidation number method that we learned earlier on today, look back, okay, according to oxidation number method, when the oxidation number increase means plus. So it is oxidation process, okay? So you know already, okay? What happened? So it undergo oxidation process. So when you undergo oxidation process, who undergo oxidation process? This fella, Fe2 plus. So Fe2 plus undergo oxidation process. When you undergo oxidation process, Fe2 plus, it is opposite, reducing agent. Okay. So next one, another apple to apple comparison. So this apple compared with this apple, obviously 0 to -1. What happened? Number decrease, right? According to number line. 0, -1, decrease, right? Okay. So you can see the oxidation number decrease. So oxidation number decrease means reduction. So who undergo reduction? This fella, chlorine undergo reduction. So when chlorine undergo reduction, you will be oxidizing agent. You will go opposite. As simple as that. Okay? So guys, let me know in the chat box, are you okay with oxidation number method so far? Not very hard, isn't it? Okay, I mean, okay lah. Not very hard. Okay, now What if I increase the difficulty a little bit? Okay, so let me see. Okay, Haida, is all the agent on the reactant side? Yes. All the agent here will be on the left-hand side here because you always compare left to the right, ma. So you always focus on the left. So all the agent, oxidizing agent, reducing agent, they're always on the left. It's never on the right because you never compare right to the left, ma. Okay, so that's why you always focus on the left. All right, good question, Haida. Okay, good one. All right, so now this is very straightforward, lah. Okay, so now let me show you how I can make it a little bit more confusing, not hard, just slightly more confusing, just slightly more confusing. Huh? Okay, just look at this, and then we do 2 past year question, then we are all done with today. Okay, give me 10 minutes. Okay, give me 10 minutes to finish off with today's lesson. Yeah, all right. So let's say we have zinc, and then we have bromine, and then we have zinc bromide. Okay, so let's do it. Okay, let's do it. Okay, so zinc and bromine become zinc bromide. Okay, now can we first list out the oxidation number? So let's list out the oxidation number, and I would like to ask you all, okay, to help me with this. So what is the oxidation number for zinc? Anyone can help me? What is the oxidation number for zinc? Okay, 0, okay, not +2. Okay, yin qi, not +2, because you only get +2 when you have charge. You don't have charge at all. So if you don't have charge, you are not an ion. You have only one species, you are element. So its element should be 0, okay? So anyone can tell me what is the oxidation number for bromine? Anyone? Bromine? Okay, very good. 0, because the bromine only got one species, right? You only have Br, nothing else. So you are element. So when you are element, you are 0. Very good, guys. Come on, the last one. What is the oxidation number for zinc on here, the right-hand side? What is oxidation number for zinc on the right-hand side? Okay, I saw 2 plus, I saw 0. Any other answer? 0 plus 2. What else? Plus 1, plus 2. Okay, now listen carefully. Listen, 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 listen carefully. I say 5 times, so important. Listen carefully. So the zinc here, can it be 0? No, you are 0 when you are element. Is the zinc one species here? No. Zinc combined with Br, you have 2 species here. So when you are 2 species, you are obviously not an element. So it cannot be 0. Do you know the charge of zinc? Yes. They purposely don't show you the charge, but you should know it. Zinc bromide. Okay, do we know what is the charge for the zinc? Yes. Zinc is Zn2+, isn't it? You learned this back in your Form 4. What is the charge for bromide, guys? Br what? Minus, right? Hold on. Okay, so you don't expect they will spoon feed you, give you the charge every time. No. Sometimes, which is most of the time, they are not going to give you the charge, which you have to find it out yourself. Okay, you have to find it out yourself. So zinc bromide is made by zinc, Zn2+, bromide, Br minus. So when you know the charge of zinc, can we go for the oxidation number? Yes, the charge and oxidation number is the same, +2, not 2 plus. Oxidation number, the charge come ahead of number. What about the bromide? So bromide, we know it is Br minus. So Br minus, oxidation number, copy back the charge, -1. Okay? So guys, let me know in the chat box, are you okay with the listing of oxidation number? If you're okay, type okay. If you're not okay, type X. This is very, very important. Okay, this is very, very important. Okay, I want to make sure everyone is okay, because this is exactly how the question will be tested in SPM. This is exactly how they ask the question for SPM. Okay, they are not going to give you all the charge one. You have to find it out yourself. Okay, good. Okay. So after you list out the oxidation number, then you can do your apple to apple comparison. So let's look at it. Zinc, compare with zinc lah. 0 to +2, oxidation number shoot up, right? So oxidation number increase according to the table we learned today. Oxidation number increase is oxidation. So zinc undergo oxidation. So when zinc undergo oxidation, zinc will be the opposite thing, reducing agent. Okay, so let's do another apple to apple comparison, which is the bromine. Bromine compare with bromine lah. Apple to apple ma. 0 to -1. 0 to -1, the oxidation number went down, decreased. So oxidation number decreased. So this fella, bromine undergo reduction, isn't it? Okay. When oxidation number decrease is reduction. So when undergo reduction, so the bromine, it is our oxidizing agent. That's it. Okay. So that's exactly how it works. Okay. So to finish off with today's lesson, so let me show you the trial exam paper. Let me show you the trial exam paper so that you can see exactly how to apply. So I will do 2 questions for you, 2 questions with you, then we were all done with today's lesson. So 1 question from Penang, 1 question from MRSM, okay? Right, both are trial exam questions, which are good quality questions. So first of all, what is the oxidation number change for hydrogen? So hydrogen, they only ask hydrogen, focus on hydrogen on the left and the right. So hydrogen, can we list out the oxidation number? Okay, on the left-hand side, H+. So H+ got charge is ion. When you are ion, oxidation number follow the charge +1. Okay? So what is the oxidation number for hydrogen on the right? This hydrogen only have 1 species, is element. Element is 0, isn't it? Remember, element is 0. Okay? So +1 to 0, as simple as that. +1 to 0. Answer C. Yeah, answer C. Next one. Okay, what is the change in oxidation number for chlorine? So chlorine, only focus on the Cl here. So on the left hand side, the chlorine here, anyone can tell me what is the oxidation number for chlorine on the left? On the left, what is the oxidation number for chlorine? Very good. 0, because the chlorine here only have 1 species, only got Cl, nothing else, so it's element. Element is 0. Okay, now, anyone can tell me what is the oxidation number for chlorine on the right-hand side? Well done, Vanisha, Yingqi, Shaila, Joey, Jayani, okay, Eliza, Yishuan, very good. -1. Cheng Yi, not 1 minus, -1. 1 minus is the charge. Oxidation number is -1. Remember, oxidation number, the sign must come in front of the number. So please don't mess up charge and oxidation number. Is it okay, Cheng Yi? Can I? All right. Okay, so -1, because we know FeCl3 is made by Fe and Cl. We know the Cl, the charge is minus. Very good. Okay, so it's what? 0 to -1. 0 to -1. End of story. Okay. So with that being said, we are all done with whatever thing we need to learn today. So let's take 1 minute to do a summary. So today what we have learned, today we started with the first chapter of your Form 5, chapter 1, Form 5, chapter 1, the longest chapter. We will spend 4 months. We will spend 4 months in this chapter alone. If we are faster, maybe 3 months, okay? All right? So you need to know what is redox. Oxidation and reduction, these 2 processes must happen at the same time, okay? So you have 4 methods to find out the chemical reaction is oxidation or reduction. So make sure you know the 4 methods and how to memorize. Same letter, put plus. Different letter, put minus, okay? So this table is super duper important. Must know this table. So make sure you know, today we learn oxygen method, today we learn hydrogen method, and today we learn oxidation number method, which is good lah, okay? All right? So you must able to do apple to apple comparison. Do the apple to apple comparison, which is very important. Choose 1 apple on the left, 1 apple on the right. You cannot compare left and left, cannot. You cannot compare right and right, cannot, must be left and right, okay? Sometimes, some apple you will compare 2 times. Sometimes the same apple you will compare 2 times. Sometimes, some of the apple you don't compare at all, which is okay, yeah? And the most important one is oxidation number method, because this is super popular in SPM. So you must know 4 rules. Rule number 1, if you have 1 species, you are element, your oxidation number is 0. Rule number 2, if you have charge, you are ion. Oxidation number of the ion same as the charge. Rule number 3, if you are oxygen, your oxidation number is always -2, except you are O2, which is element, or you are H2O2, hydrogen peroxide. If you are hydrogen peroxide, the O is -1. Rule number 4, oxidation number of hydrogen is always +1. Special case, when you are H2, hydrogen gas, you are element, so 0. When you have metal combined with hydrogen, you are metal hydride. The hydrogen here is -1. Other than that, hydrogen always +1. Okay, so I need your feedback. So guys, can you please let me know in the chat box, how's everything for today? How is it? Okay, not very hard, isn't it? Okay, you follow the steps. You follow exactly the steps I told you, you will be fine. So for the first few lessons, I'm not going to give you tutorial, but after that, I will let you to do tutorial. I'll give you 3 to 5 questions for you to do. Not too much that make you very stressed, but you must always do some question one, okay? Because I know if I'm not giving question, it's very hard that you will take initiative and do on your own, very hard. So I'll give you a few questions, just to help you to really test your own understanding, okay? But not for today lah, okay? After 3 to 4 more lessons, then only I start to give you a few questions as you know, your homework or tutorial, okay? So you see, this is the way that we will learn in your Form 5. We learn something and directly we go to look at the past year question. We look at past year question, we look at trial exam paper, those good quality questions, so you will know exactly what you learn and how you apply those concepts in the real examination. I think learning in that way is much more effective than pure reading. Okay? So I think that's all for today. All right. So I'll see you guys again by next week. Yeah.